All right, welcome back to Database History. Today, we're diving into a platform that really changed the game when it comes to data exploration speed, OmniSci. We're going to look at how this thing pulls off almost instant insights from just enormous data sets. So, yeah, let's jump right in.
I love this quote, exploring the engines behind instant insight. It just nails it, right? It's not about just storing data. It's about the engine that powers discovery. It's about taking that gap between having a question and getting an answer and just crushing it down to almost nothing. That's the promise here. And that's what we're going to unpack.
Okay, so what is this engine? Well, at its heart, OmniSci was born from this one simple but super demanding need, speed. I mean, think about it. If you're wrestling with these huge, massive data sets, you can't be waiting around for minutes, or worse, hours for a query to finish. It's not going to work. Let's get into the guts of it for a sec. So first, it's a columnar database. All that really means is it's built for analytics. It reads data up and down, not side to side, which is way faster for things like averages and sums. Distributed just means it can spread the work across a bunch of machines so it can handle insane amounts of data. But, and this is the big one, the real secret sauce here is GPUs. Yep, you heard that right. Graphics processing units. The same powerhouse chips that make your video games look amazing are used here to just tear through data in parallel. It is a total game changer.
So it really boils down to these three things: speed, scale, and visual exploration. Now, we've hit on speed and scale, but that last one, visual exploration, is just as crucial. See, OmniSci isn't just about spitting out numbers in a spreadsheet. No way. It's about making the data come alive, making it intuitive, interactive, letting you see the patterns in real time as they're happening. It's pretty cool.
You know, every great piece of tech has a cool origin story, right? And OmniSci is a classic. It all started at MIT, one of the top tech schools on the planet. This thing wasn't cooked up in some corporate boardroom. Nope, it began as an answer to a really tough, really specific academic problem. So picture this. It's 2013. A guy at MIT named Todd Mostak has this insane challenge. He wants to visualize the entire Twitter fire hose. I'm talking every tweet everywhere in real time. The tool he built to do it was first called MapD. But here's the thing. The engine he created was so incredibly powerful that it was useful for way more than just maps. It grew into this full-on analytics platform, and that's when they rebranded to OmniSci, kind of like All Science, to show just how broad its capabilities had become.
Okay, so that's the backstory and the tech. But what can it actually do, like in the real world? How does all this speed help people solve actual problems?
Well, for starters, it supports full SQL, and that's a huge deal because it means analysts can just use the language they already know and love. But where OmniSci really flexes its muscles is with these super advanced queries. We're talking geospatial stuff, like maps and time series data. So you could ask these crazy complex questions, like, hey, show me every single bit of mobile network traffic in downtown Manhattan over the last 5 minutes. And bam, you get the answer instantly on a dashboard you can actually interact with. And those kinds of capabilities lead to some amazing real-world uses. You've got telecom companies watching their entire network live, logistics companies optimizing thousands of delivery routes, like right now, public sector agencies creating public safety dashboards to respond to emergencies faster. This isn't science fiction, you know? This is stuff that's solving critical, time-sensitive problems today.
And if you want to get your hands on it, there are basically two flavors. For all you developers and data scientists out there who want to play around or build a personal project, there's a really solid open source edition. Then, for the big companies that need all the bells and whistles, top-notch security, and support for massive deployments, there's the enterprise edition.
All right, but let's be real, OmniSci isn't the only game in town. The whole data analytics space is super crowded, right? So it's worth taking a minute to see how it stacks up against some of the other big players you've probably heard of. Okay, so take Kinetica. It's also GPU accelerated, but OmniSci has always been way more focused on the interactive visual side of things. Then you've got something like ClickHouse, which is super fast, but it runs on CPUs. OmniSci's big advantage there is being built from the ground up for GPUs. And then there's the giant in the room, Snowflake. But they're really playing different games. Snowflake is a beast for huge, planned-out batch jobs. OmniSci, on the other hand, is all about that real-time interactive exploration, that what-if analysis. So what's it actually like to use it? Honestly, it's surprisingly simple. You just connect to your data, you write the standard SQL you've been writing for years, and you get these visual results back, like, instantly. Plus, it plays nice with all the tools that data scientists already use and love, like Python and Jupyter Notebooks, so it just slots right into their workflow without a big hassle. And this, right here, is the thought I really want to leave you with. The true power of a tool like this, it's not just about answering the same old questions but faster. No, it's about giving you the freedom to ask totally new questions. The kind of deep, complex, what-if questions that you never would have even tried before, because who has time to wait an hour for an answer? It completely changes your relationship with your data.
And that's our deep dive on OmniSci, a true pioneer in GPU-accelerated analytics. Hey, thanks so much for joining us here on Database History. We'll be back again soon to dig into another piece of the data puzzle. Until then, keep those queries curious.